We're going to take a look at lesson 3.3 titled All Things Being Equal. It's on page 311 of your textbook. Towards the middle of the page, where it says 3.3 class, we're given four statements. First statement says New York City is the capital of Guatemala. The second one says over 1 million distinct species of animals have been cataloged and named. The third one says 8 equals 5, and the fourth one says 13 minus 10 equals 3. Well, clearly the first and third statements are false, and the second and fourth ones are true. First two are verbal, the last two are mathematical statements. This illustrates two key ideas behind equations and understanding equations. In the purple box, it gives us these two key ideas. The first one is that an equation is simply a statement that two quantities are equal. And the second thing is that, like verbal statements, equations can either be true or false. The statement in number 1 contains a variable quantity. Is it always true or always false? The number of hours you'll spend on homework this week is 14. It's not always true or always false any given week. We're going to say it's sometimes true, sometimes false. Some weeks you may spend 14 hours, some you may spend more, some you may spend less. So it's an odd statement. Turning the page to page 312, the top of page 312 says, an equation written to represent a statement like this is called a conditional equation, and it's the type that we most commonly study. If we use the letter h to represent the hours you spend on homework, we can write our equation as h equals 14. In this case, it's pretty clear that the value of h is 14. And if it's not, it's false. 14 is the only number that will make it true. So some definitions about equations. The first definition is a number that makes the equation a true statement when substituted in for the variable is called the solution to the equation. The second definition is the set of all numbers that make it true would be called the solution to an equation. When an equation looks like h equals 14, the solution is pretty obvious. But when an equation looks like something like negative 12y plus 17 equals 2y minus 11, not so much. So our goal is to find a way to solve these equations. The process of solving an equation. When changing the form of an equation in an attempt to find the solution, anything you do to the equation should not affect whether it's true or false. So they tell us that 5 equals 5. We already know that. We know that 5 equals 10 is not true. So let's start with these two equations. The true one is 5 equals 5, and the false one is 5 equals 10. What happens if we multiply both sides of the equation by 2? Well, in the first one, I get 10 equals 10. Still a true statement. So far, so good. What about the false statement? If I multiply both sides of the equation by 2, I get 10 equals 20, which is still a false statement. So multiplying both sides by 2 did not affect the truth value of the equation. Number 3 says we know that the equation 1 foot equals 12 inches is a true statement. So is it true that 3 feet equals 36 inches? Well, if we multiply both sides by 3, I can do that. And I get 3 feet equals 36 inches, which is also a true sentence. Now 4 gives us an interesting problem to look at. The equation 1 mile equals 5,280 feet is true. That's a true statement. One yard equals 1 meter is a false statement. What happens if we multiply these equations by 0? Well, let's multiply the true one by 0. I get 0 equals 0. So, okay, it's still true. It kept my true statement true. But what does it do to my false statement? I went from something that was false, and now I have 0 equals 0. Uh-oh. I turned my false statement into a true statement. So we cannot multiply by 0 and keep the truth value. So that's what they're going to bring together for us in this purple box. These purple boxes are always helpful because they give you steps or what you've been dealing with, the rules that we've been learning. So what we just learned is that we can multiply both sides of the equation by the same number as long as it isn't 0. So they give us an example here. I have d divided by 360 equals 0.35. To undo divided, I would multiply both sides by 360. Which will leave me with d equals, you can use your calculator to do 0.35 times 360. And it should give you 126. To check that, you're going to take 126 divided by 360 and see if it equals 0.35. It should. If it doesn't, we've done something wrong. Number 6 says, is the solution you found in the purple box the only solution to the equation? How can you tell? Yes, because when I plugged it in, it worked, and there's no other number that will work. So no other numbers work. So let's move down to number 7. We're going to look at some other rules. We know that 1 minute equals 60 seconds is true. Is it true that a half minute equals 30 seconds? Well, if I divide both sides by 2, I get this statement, 1/2 minute equals 30 seconds. Is that true? Yes, it is true. So it looks like we are okay to divide both sides of the equation by the same number. So we can divide, and my pen just went crazy, we'll erase that real quick. We can divide both sides of the equation by the same number as long as it's not 0. So right now they give us an example of 5 times x equals 60. What is the opposite of multiplying? It would be dividing. So we divide both sides by 5 and get x equals 12. To plug it in, we're going to do 5 times 12 and see if it equals 60. It does, so we're happy. We know our answer is correct. So we are building a toolbox. We can now multiply or divide both sides of the equation by the same number and keep the truth value, as long as it's not 0. At the top of page 314, they jump in and bring something a little bit different in. It's this idea of a proportion. When you have 2 ratios that are equal to each other, we can call this a proportion. It's 2 fractions set up that are equal to each other. We solve this by a way called cross multiplying. When my youngest daughter was in elementary school, she learned this as butterfly, because it looks like a butterfly when you circle the means and extremes. So we're going to go ahead and do this. 9 and 10 are bringing us together to solve it. So when I do 100 times d, I get 100d. And then I have to do 360 times 35. And let's go ahead and solve that. So I get 100d equals, get your calculator out, and go ahead and do 360 times 35. It gives me 12,600. Now I've got 100 times D. What's the opposite of times? Divide. So divide both sides by 100. And look at what answer we get. The same answer we got before without doing it as a proportion. So let's do number 10 as a proportion. We're going to multiply, we're going to make it turn into the butterfly. X times 36 is 36x. And then for the other side, we're going to do 12 times 15, which is 180. Now we've got an equation we can solve. I have 36 times x. What's the opposite of times? Divide both sides by 36. And we get x equals, you can throw that into your calculator, you should get 5. All right, moving back to building our toolbox. We're going to look at number 11. We have found that we can multiply and divide both sides of an equation by the same number and not change the truth value. What about adding? They tell me that 1 minute equals 60 seconds. We know that's true. If I add 3 to both sides, I get 4 minutes equals 63 seconds. That makes absolutely no sense. And the reason it doesn't is because they're not the same unit of time. Not same unit of time. You'll notice in number 12, they do it a little bit differently. They say, oh, if I add 3 seconds to both sides, I get 1 minute and 3 seconds equals 63 seconds. Now it works. And the reason it works is because we did now add like units. All right, so building our toolbox. At the top of page 315, we've just discovered that it's okay to add the same quantity to both sides and keep the truth value. So they give me an equation here that says x minus 142 equals 70. What's the opposite of subtracting? The opposite of subtracting is adding. So I'm going to add 142 to both sides of the equation. And I get x equals, do 70 plus 142, it should be 212. To check that, I take 212 minus 142, should be 70. It does work, so we're happy. So we now have 3 tools in our toolbox. We can multiply, we can divide, we can add. What do you think is going to come next? We can subtract. 14 starts building our subtraction toolbox. It says, given the fact that 36 inches equals 3 feet, subtract 5 inches from both sides. We have to be careful doing that. 36 minus 5 is pretty easy. That's 31 inches. But doing 3 feet minus 5 inches, I have to be careful. It's going to go down to 2 feet. And then I'll have 7 inches left over after I take out the 5. Is it still true? Yep. So what we've just added to our toolbox is that we can subtract the same quantity from both sides and keep the truth value. So we can now multiply, divide, add, subtract to solve equations. So we've got n plus 1,361. How do I undo addition? The opposite of adding would be subtracting. From both sides of the equation. So we're going to take 2,094 minus 1,361. Should get 733. If you plug that back in, 733 plus 1,361. Does that equal 2,094? It better. If it doesn't, we've done something wrong. So it is indeed a true statement. At the top of page 3, I lost the numbers. Page 316, I thought that's what it was. They bring this all together for us. They said the types of equations we've been solving are called linear equations because we've seen that the graph is a line. Here's the steps. So you're going to do things that are a little bigger than what we've just done. In fact, we're going to do the one in the orange box for some practice. Step 1 is do any kind of simplifying you can do. If you've got parentheses, distribute and combine like terms. Step 2 is add and subtract to get your variables on one side, your numbers on the other. Step 3 is your division step, and that's when you know you're done. So let's try to work this example here. They don't give me a whole lot of room, but we'll work it out our best we can. This is a longer equation, but I think it's good for you to see an example of how to do it. The first thing you have to do is distribute the 4 through the parentheses. So I get 4x minus 12 equals 10 plus x. This one happens to be called a 3-step equation because I have variables on both sides. So my first step is to move the x from the right side to the left side. You're subtracting 1x is how you're doing that. I'm going to come back up to the orange box. 4x minus 1x is 3x minus 12 equals 10. Now my variable only shows up on the left side, so I need to move everything away from my x. So the first thing I do is undo minus 12. What's the opposite of subtracting 12? Adding 12. You get 3x equals 22. That's 3 times x because it's smashed up against the x. I undo times by dividing. And you can either get a decimal or you can leave that as 22 over 3. In the group work, you're going to get into more equations and more practice solving equations.